welcome to the definite integral. So we're going to sort of take a more in-depth look at that area under the curve we've been talking about previously. So let's suppose that f is defined on the closed interval AB, then the signed area under F between A and B is essentially the total area above the x-axis and below F minus the total area below the x-axis and above F. I need to give myself more room. So now that we have more space, just a note that this is basically what we were finding in the previous area. This subtraction sign is essentially accounting for the negative height for the things that are below the x-axis. So this is accounting for the negative height for things below the x-axis. So you don't have to use negative height when you're calculating the total area below the x-axis because the subtraction sign will take care of it. All right, so this is the signed area under the curve or under F. And then what we get next is also the definite integral of F evaluated between A and B. So the definite integral of F between A and B is, we use a new notation. So once again, we have this tall curvy S. We put an A at the bottom and a B up top, indicating we're looking between A and B. And then we have f of x dx. This looks an awful lot like our integral notation. We just have these bounds noted this time. This is defined to be the signed area between A and B. So the definite integral, this is the notation we use for finding, to tell us that we need to take the signed area. So again, this here is just notation. So this is just a new notation. And we call it the definite integral, just means take the signed area. So let's go ahead and consider the piecewise function. F of x equals x plus 1 if x is less than or equal to 2. Then it's a constant 3 between 2 and 4. And then it equals negative x plus 5 for x greater than 4. Actually, I'm going to change that. That is not what I meant to have. I apologize. It should be negative x plus 7. I was trying to make it continuous, but wasn't paying attention. So negative x plus 7 for x greater than 4. All right. Okay, I'm going to pause and re-edit this. I apparently was doing 2 problems at once when I wrote this. Okay, so let's go ahead and just graph this so we can see what we're working with. So for our function, I'm going to count by 2's. And I'll just count by 2's both ways. So before x equals 2, we know that we're looking at x plus 1. So we'll go up to 3. We have a y-intercept of 1. So we're looking at this line here. And then we have the constant line at x equals 3. Sorry, at y equals 3 between x equals 2 and 4. And then negative x plus 7, that was meant to be plus 7, so that when we plug in 4, we are still at 3. And we have a slope of negative 1. So we'll make our way down. Here we go. All right. So the first thing we need to do is figure out that area between 0 and 2. So from 0 to 2, we are working with a trapezoid. So for a trapezoid, you just have to do the average of the bases times the height, or you can split this and do a little rectangle plus a triangle. So we're working here with a trapezoid between 0 and 2. It's all positive. And so we have the area is equal to the average of the bases. So B1 plus B2 over 2 times height. So our bases are the 2 parallel lines. So we have 1 and 3 divided by 2, and then the height is the distance between those, which is 2. So this is our H, B1 and B2. And so we wind up just getting that the area is 4, a positive 4. It's all above the curve. And so our definite integral from 0 to 2 of f of x dx is equal to 4. Next up, we want to continue that on and go all the way to 4. And now we want this whole part. And so basically we have that purple trapezoid plus the green rectangle. Right? So we're going to continue on with our little purple trapezoid. And then we'll add on that little green rectangle. So we already figured out that our trapezoid had area 4. And then our rectangle, we have a width 2 times a height of 3. So we are looking at 4 plus 6 or 10. Next up, let's go ahead and look from 4 to 12. So we'll do this in orange. So we have some above and some below. Here's our 12. The point where we're ending here is 12, -5. So this region, we have some positive and some negative. So we'll have a little triangle, which is positive, and then we'll have a big triangle, which we're going to subtract off that area. So our little triangle has height 3 and base 3. And our big triangle has base 5 and height 5. So we are looking at 1/2 times 3 times 3. And then we are going to subtract off 1/2 times 5 times 5. But again, this chunk here is above the curve, so we're going to add it on. Oops, there we go. And this chunk here is above the x-axis, so we add it on, and the next one is below the x-axis, so we subtract it off. So we are looking at 9/2 minus 25/2. Or 4.5 minus 12.5, and we wind up getting -8. So for this one, we have -8. So now if I want to go from 0 to 12, that's all those pieces that we just had, right? So from 0 to 12, we have our purple trapezoid plus our green rectangle. Then we add on our smaller triangle and then subtract off our large triangle. And so this was 4 plus 6 plus 4.5 minus 12.5, or 10 from the 4 plus 6 and -8 from the 4.5 minus 12.5. And we wind up getting that this is just 2. And so the definite integral from 0 to 12 ends up being +2. If we'd gone past 12 by much, we would have wound up with enough negative area to cancel out all the positive. So it's possible for your definite integrals to wind up negative if you have more area below the x-axis than above. But so this is just using geometry to evaluate these definite integrals. Again, taking advantage of the fact that a definite integral is really just signed area under the curve.